morning. Welcome back. It's Friday, like right before spring break.
Yes.
Are you guys like at that point too?
Yes.
Yes. Okay, so let's get through this together as promised, because I know that we've been doing systems of equations, and on the quiz that you guys took, I have them graded, so I'll pass them back here in a few moments. The open response items, the ones where you had to do this.
The really long ones.
Yeah, the really long ones, they're a mess. And I know that you're still working on the Unit 10, Day 2, which was like 20 of these that you had to do by hand. And this was my notes from just one problem. So I get that each of these problems are going to take you a significant portion of time. Okay? So I'm going to move the due date for Day 2 until Monday when we come back from spring break, giving you the entire week to find those moments to sit down and work through these. Because I know that each set is going to probably be a full page worth of work. Okay? And go ahead and allow it to be that full page worth of work. I'd offer to have you call me if you need some support over spring break, but I'm out of town in a location that has no internet. So, yeah, I'm going out on a retreat.
Oh.
Yeah. So, no internet, no phone. We'll talk about it later. But you still do have access to the videos that I've already recorded. Khan Academy is a great resource if you're not you don't remember how to actually do the solving. You can go on there and find videos and explanations and practice on how you do the manual solving. And then if you just look up how do I solve an equation in YouTube, there's probably tons of videos, some of them might be mine, that can help you out. Okay, so Day 2, this item will be due on Monday when you come back, and then I hand you this thing. And I saw the looks on some of your faces when you looked at this. You're like, there's even more of these. Can you imagine doing these by hands? Like, can I just have these please next Christmas at that point, right?
I'd probably end up doing one this week.
And rage quitting. I don't want you to do these by hand. This assignment, there should be no algebra work done. I'd like you to use either your calculator. I want you today to practice on the calculator. And then I'll show you how to do it on your phone, so that way when you go home over spring break, assuming that you don't have one of these superheroes at your disposal, you can then use your phone,
Desmos.
or you can use, I don't think Desmos can do this question mark. I haven't checked. But you're welcome to look to see if Desmos does it. I'll show you a website that you can use on your phone or your tablet or your computer that will do exactly what we're doing right now. Wait until we get through the explanation, if you don't mind, please. Please, I appreciate it. And then you can check in Desmos, and then you can tell me, yes, it works, and you can, I'll switch places. I'll go now sit in your seat, and I'll take notes, and then you come up here and you push the buttons in front of everyone and show us how to use it on Desmos. Okay. All right, so first thing we need to do, we're going to do some very minimal writing. There's not much to write on these. So grab your pens. We're going to trade these system of equations for something called a matrix. Yes, kind of like the movie.
I was about to say that.
Did you all watch the movie? Matrix?
Where he dodges everything?
Where he dodges everything, like super cool, and that was like our first CGI people moving weird. No? That's okay. So the premise of the spoiler alert, the premise of the movie is they're all in a computer simulation virtual reality thing, and they don't realize it except for a few people who know, and they're trying to fight against this virtual reality. And anytime they realize that there's computer code going on, you see the computer code. And what the code in that movie looks like is these like dripping, almost raindrop columns of letters and numbers.
Oh, I know
Okay?
that.
Remember that? That's the code from the Matrix. We're going to be writing stuff like that. We're changing this reality into our Matrix code that then we can stick in our calculators and have it do stuff. Okay? All right, so here's how you write that Matrix code. Set up your matrix. Yes, you have to write the square brackets. The first column of numbers. Notice how all of our variables are all lined up, so all of the same kind of variables are in the same column. You're then going to look at the coefficients, the numbers in front of those variables. The first variable's coefficients are going to go in this first column.
Wait, so not the X,
Just the negative.
Exactly, just the numbers, not the letters, just the numbers.
So for X, we put 1.
Correct. All right, these are going to go in a second column. The coefficients of our next variable are going to go into a third column. The equal signs, I'm going to turn into a bar, just like a line. And then the answers, my constants, are going to go after the bar. Okay, so let's fill in our matrix, our table. So for this negative, what number should I write?
Negative
1. And for the next number, underneath it?
4.
And then the next number?
1.
Beautiful. Start the next column. My number should start as?
Negative 5.
And the column continues as?
Negative 5.
And then it finishes with?
5.
Don't put the positives. Only put the negatives. The next column starts with? Good. Continues with?
4.
And finishes with?
Negative 1.
Beautiful. And my answers column?
2.
19.
19. 20.
Perfect. That's the hardest part about this thing.
Oh yeah, negative 20.
Negative 20.
Negative 20. Thank you. I think you said 20 and I wrote negative 20. That's it. That's the hardest part.
That's easy.
I know, right? But that's the hardest part about this.
It's probably hard because you need to know what order and what numbers.
Exactly. The hard part about this is knowing where your numbers need to go. They have to be in order, whatever order you've picked for your variables. It doesn't matter, but you have to put them in order. And you have to make sure that all of the same variables are all in the same column.
Hello?
Yes?
We need Leslie Solis. She will be leaving.
Thank you.
Thank you.
So if that is written out, Y, X, Z, can we just write the numbers straight down like that, or do we have to arrange it differently?
All right. So in case you didn't hear, his question was, if my equations are written in the order Y, X, Z, can I write it Y, X, Z, or do I have to rearrange it to be X, Y, Z? Totally your choice. You get to make that decision, but once you've made that decision, all of your variables have to stay in the same column. Okay? Whichever column you've decided to put them in. Traditionally, we put it in alphabetical order, X, Y, Z, but honestly, it doesn't matter. Okay.
Like on this one, they're all mixed up.
On, which one are you looking at?
The one on top of the...
This one?
No, the one under it.
This one.
Yeah.
Okay, this one, they're not all mixed up. In
Just
these
the
two,
Y.
the top
Yeah.
one is missing a variable.
X.
Yeah, in this one on the right, it's missing the X, and on this one on the right, we're missing the Y. So what this means is, in whichever column that those variables are part of,
Do you leave it alone? Do you put a 0?
you put a 0. Because 0 is our number for ain't nothing there. Okay? So if it's a variable by itself, so just the letter showing up, it's going to be a 1. If there is no variable, it's a 0.
Do you want us to put that 0 with the line?
No, it's an actual literal 0, not the 0 with the line that means empty set. Yeah. Thank you. That's a fantastic question, and I love that that came from like way back in August. Holla. All right, let's do the work of calculating the answer. Come to your calculators.
Wait, that's all the writing you do?
That's all the writing we're doing on this one. We're gonna write the answers, but like, that's it. That's like, this is all the answers. This is all the writing that there is. Okay, hang on. I gotta put a screen to block some of the light that's coming in. Okay, that's a little better. And then let me make this a little brighter so we can see it. Okay, good. So come and grab a new worksheet. You don't have to save the work of the class from before you. Add a calculator page, please. And if you want to write down these steps on a separate sheet of paper so you have them in your notes while you do homework, that is okay with me. Button to push is menu. Since we're dealing with the matrix, we should be under matrix. Matrix, number 7 for matrix. And then you want to go to reduced row echelon form. Not row echelon form, but reduced row echelon form. And then your calculator is going to be like, riff. Okay. Now, find the button next to the number 9, between the number 9 and the book.
The one with that looks like a smiley face.
Yeah, the one that looks like a sideways smiley face with like the unibrow happening. Right?
Wait, what?
Okay.
This one?
Matrix number 5 for row reduced echelon. And your calculator then is going to say RF. Stands for row reduced echelon. Okay, you're looking for next this button right here between the book and the 9. So the one that my fingernail is on right now. This button. Okay, so you're going to push that button and it is going to bring up my shade thing is totally not working. It's going to bring up a little menu and you want to select the item that looks like a 3x3 matrix.
Ooh.
Now it's going to ask how many rows, how many columns. How many rows did we have?
3.
How many columns did we have?
3.
Wait.
4, because we have the column for the answers.
How'd you get there?
So to get there, I push the button next to the 9 and the book. And then I selected the one that looked like a 3x3. Okay? So now you have this thing. You have ref, parentheses, and then the skeleton of a matrix.
Wait, what was step 6?
Yes, looks like that.
It was after the thing choosing the.
We haven't talked about it yet. All right, now we're on, she's been taking careful notes. We're on step 6. Now that you have this thing,
Yes.
fill in the numbers in the exact order that you just wrote them in. That's all you got to do. Fill in the numbers. Oh, you because of the code, the matrix code, the dripping. I get it. Before you hit enter,
Already entered.
you already hit enter. Did you get some sort of weird fractions?
Yes.
Yes. Some yes, some no. All right, before you hit enter, if you already hit enter, it's fine. You may have gotten some weird fractions, you might not have. Double check to make sure that you've got all the numbers in the right places and all of the negatives with the correct numbers.
Miss, we literally typed in the same thing, and he
Oh,
didn't
I
get
got it.
Okay? That's what you should get. That's the matrix that should spit out.
Is that the same as mine?
Yep.
Oh, okay.
Miss Sarah got something different.
Yep, I saw.
But it's the same.
Binary.
It's the same thing. Okay, let's take a look. Ugh, my arms are short.
Just in fractions, no?
Who's there?
Ah, yours is 1R. You picked row echelon form instead of reduced row echelon form.
Oh, she chose 5 instead
Yeah.
of 6.
They do slightly different things. So go back to menu, go back to matrix, and you want the reduced row echelon. So your calculator says ref.
Okay.
Yeah.
This one says red.
Should I have the same thing?
No, it's not.
Yeah, it does.
There's a double R.
It does something slightly different. The ref and the row ref.
Miss, I just typed it out. RRE.
Oh, and it worked?
Yeah.
Okay, right on.
Yeah.
I didn't know that. Apparently, you can just type in the letters RREF, and it does the same thing.
Wait, really?
Because honestly,
Let's
I didn't
try
pay
it.
attention to what you did. And
You just started typing.
Yeah.
Okay, I just typed in RREF.
And I put
We're going
the-
to do parentheses,
Yeah, I did the thing.
Oh,
and
yeah,
then
it worked.
the thing,
Yeah.
and then, okay, it looks like it's, okay, so there's a shortcut for you.
Yes.
Okay, right on. So you don't have to go through the menus, you just type ref. All right, so everyone has this? That's all there is to this, man.
So that's the answer?
That's the answer.
So we write the answer down on the bottom.
Yep, so we're gonna write this. You did not get this?
Probably the
Did
same
the
thing.
person next to you get this?
Yes. I did.
Okay, so compare. Look for differences. It does work, apparently. So if you just type ref, it sounds like it works.
Yeah, right, I got it.
Okay. So then I'm going to write this as my answer matrix. -3, 3. Okay. There is our answer. How many solutions does this system have? Remember that we've got 3 equations and 3 variables, and the solution is the one point where all 3 of those lines come together. And in order to describe the one location where these 3 lines intersect, we need 3 different numbers. We need a value for x, a value for y, and a value for z. This is those values. This column was your first variable, which you had called x. This column was your second variable, which you had called y. This third column was your third variable, which you had called x. Recall from up here?
Z.
This, I'm sorry, Z, thank you. I said X, I'm so sorry. Z, you're absolutely right, Z. So this is the column for X, this is the column for Y, this is the column for Z. And the bar represented
Equals.
the equal sign. And then these numbers at the tail end were the answers to our equation, which means these are the answers. So if I read it left to right, how many X's are in the first row?
3.
How many X's are in the first row?
Oh, 1.
There is 1 X. And that 1 X has a value of? How many Y's?
1.
Which has a value of?
-3.
And how many Z's?
1.
With a value of?
3.
My solution is -2, comma, and a -3, comma, 3.
Oh.
So we can basically just write the answers from up to down.
Straight down, yeah. As long as you put them in the right order.
Oh, this is so
Okay?
easy now.
I have a question.
I have an answer.
Okay, well, like the number 1,
Mhm.
like the answer, on the bottom, will they only be ones, or they also be like other numbers?
I love that question. Thank you. In order for your matrix to show you the solution, it has to be, the front part has to look like this. You have to have 1s along the diagonal from left to right and 0s everywhere else. This is what's called the identity matrix.
It's called the binary code too, I think. Those are the numbers we use for
Binary numbers.
binary codes.
Yes. Yeah, it's also related to binary codes. So you have to have this identity matrix, and then these numbers are the solution.
Will they ever be like cross, like all 3 together?
Yeah, I'll get into that in just a second.
But if you made your own order, wouldn't that diagonal line of the ones change?
Great question. If you put it in your own order, so let's say here at the top you put Y, X, Z, you're still going to be looking for this identity, but this is now Y, this is now X, this is now Z.
That
So it's-
one would move to a different spot.
Yeah.
Okay.
Okay.
Are you trying to open the quiet?
Now to answer his question was, will it ever look like something other than the identity matrix? Yes, it could. But once you get something that stops looking like this identity matrix, you stop having an actual solution, like a single one solution. You start having the possibility for infinitely many or none. And so here, for your 3x5 index cards, are the cheat codes for knowing when you have infinitely many and when you have no solution. The top one is when you have no solution. Notice your identity matrix. And then your very last column being a bunch of numbers.
Do you have an index card?
I do. There.
Yeah. Can I have one?
Miss, is this
I'm
not-
out. I'll get you some more later. Yes, you can have that on. Okay. So one solution, you see the identity matrix in the front, and then you have a column full of numbers. Numbers that are available are any number in existence. You can have positive, negatives, fractions, no one cares as long as you have the identity matrix, full of ones and zeros, the ones on diagonal, and then a column of numbers. If you get something other than the identity matrix and one entire row, I don't care where the row is located, but one entire row ends up all zeros, it's usually the one on the bottom because that's how the technology works, but really the all zero row can be anywhere. As soon as you see a row of all zeros, all of them, you have infinitely many solutions. This one is related to one of the examples we did in day 2, where we ended up with the variables disappearing and numbers that agreed. Okay? Because we have zeros here, this tells you how many variables we have. We have no variables. And these quantities agree, 0 and 0. Okay? Suddenly, infinitely many solutions.
Even if just one of those.
Even if there's just one line that does it.
Oh, okay.
On this matrix, with no solution, this matrix with no solution, you're going to have, again, something that doesn't look like the identity matrix. One of the rows, I don't know where, okay? The technology likes to put it at the bottom, so when you're using tech, it's probably going to show up at the bottom. But again, it can be anywhere. You will have one row that's all zeros except for the very last number. It's going to be something else. Anything else. It's usually a 1, but not always. This is akin to, we've worked it out by hand. We don't have any variables, but we have numbers that disagree. Right? Because we have no variables, and these string of zeros do not equal whatever number I have here that's not a 0. That's the no solution. Okay, we're good? All right, I have a website to share with you. You are playing with Desmos now? You're playing with Desmos? Huh?
It's another thing.
Oh, it does something else, so it doesn't, Desmos doesn't do this.
No.
Okay. Yeah, I didn't think it was going to. All right. I'd like you all at this time to pull out your phones if you have them. And you're going to surf to this website. Or you can Google free online matrix calculator. The bottom line is what I searched up when I found the linear algebra toolkit. All right, so here's my Google. Try to get the website to still show. Okay, so linear algebra toolkit, math.odu.edu. So there's my Google free online matrix calculator is what I typed. And the first one, linear algebra toolkit. So that's what I'm going to click on. And if you don't get to this page exactly, what you want to do is you want to look for the option that says transforming a matrix to, I think it's like enter the website.
I went to like college website.
Yeah. So you went to math.odu.edu?
Yeah.
Okay. So you should have something that says like enter or something. Yeah. Okay, yours is doing the same thing. Matrixcalc.org. She's got a different website, which is totally fine. Okay, and you're looking for something called, once you've entered their website, you want something called transforming a matrix to row reduced echelon form. Well, Valerie may have found a different website, and she's playing with it right now.
I don't know.
That's okay. Okay, so once you've gotten to the page transforming a matrix to row reduced echelon form, yes?
Miss, which one did you get for the calculator?
Oh, you did. Oh, so you found the same website as she did. So go ahead and click that top one, that matrix calc. It's probably going to do the same thing. All right, here we go. We're going to specify our matrix dimensions. Make sure you tell it the number of rows and the number of columns. We're going to do the same one we just did.
Ooh.
Since we already know the answer. All right. And there's our matrix already set up. It's a 3x4. And we're just going to type in the numbers that we had. Mine's going to auto-populate because I've done this example. We're doing the same one that we've already done. Okay, just as a confirmation that this works. Auto-populates.
You can even.
All right, there it is. Hit submit. Now, the Old Dominion University website that we're using, ODU, spits this out. All right, do you have something that looks like this now?
I'm still typing.
You're still typing? Okay. Can I see yours? The one that you found? She's like, let me clear my Twitter.
No, I
Thank
was
you.
trying to unlock my phone.
No problem. Okay. Oh, goodness.
Because instead of marking it, just
Okay. So,
Miss, are you still recording?
yes, I am.
But it would have run by the Echelon.
Okay, so
Whoa.
the website that you found, this matrix calculator, I'm not sure it's gonna do what we're wanting it to do, because this is actually going through all the steps that this is showing, okay? Which is beyond, it's beyond what this class is requesting. So, go to the math.odu. Yes, yes. So it looks like this.
Yeah.
Okay. What this is showing you is step by step what the calculator is actually doing. So when the calculator solves linear systems for you, you put like linear solve.
Show your work.
It doesn't do this. It doesn't do this. It does this. Okay? Our answer is this one on the bottom right.
It gives you all of that for one.
It gives you all of the steps, which you don't need. For our application right now, you don't need all the steps. You just need the one on the very bottom right. Okay? So this is the one on the very bottom right. Okay? That's this one right here. And there's your answer. Which is the same thing that we found using our calculator. There it is. Okay? That's it. That's all there is to it. Have fun, guys.
Bye.
Bye.